Hi, my blooming buddies. So once again, you are back here with me at your own favorite learning platform, Learn Forward. And we are right here with your maths book, Maths Concepts and Skills for Grade 4 by Feathercaps. What new today? We are going to learn about factors and multiples. So that is chapter 5 of your book. So before we get started, let's have a gear up exercise for you. What do we have? Let's check out. Choose any number, say 5. Okay, and color the respective block in the following grid. So do you see a grid here? What do we have here in this grid? Numbers from 1 up to 50. And what are they asking? They are asking to choose any number, let's say 5, and color the respective block. So let's shade this out. Now, next what you have to do? Multiply the chosen number by 1. So 5 times 1 is 1. 2, 3, 4, 5. You have to multiply like this. So 5 times 2 is 10. 5 times 3 is 15. Good. 5 times 4 is 20. Then 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. Then you have 40. Good going, and you got them perfect. So we have shaded all of them. Color the respective blocks as shown in the grid. All the colored numbers, do you know? These numbers we have got after multiplying 5 by any number, and these shaded numbers, the selected numbers, are called multiples of 5. So we get these numbers after multiplying. So you can correlate the word with multiply, and remember they are the multiples. Okay. So these are called the multiples of 5. And the numbers that are multiplied, they are called the factors. What do you mean by that? For 15, which numbers have we multiplied? We have multiplied 5 by 3. We got 15. So children, what do we say? 15 is a multiple of 5. 15 is also a multiple of 3 because we are getting here 15 when we multiply 3 by 5. So it is a multiple of 5 as well as 3. And you know what 5 and 3 are? 5 and 3 are called the factors of 50. Okay. So you have to remember these terms now. One is multiples and the other one is factors, right? So let's move ahead. What are factors? I have just told you the numbers that are multiplied, they are called the factors of the product. So if you have the numbers 2 times 3 is equal to 6. So how do you say? 2 and 3, both of these numbers are the factors of 6. And what is 6 called? Perfect. 6 is called the multiple of 2 as well as 3. So this is a new term for you. The factors of a number, they divide the number exactly. So if we say 2 is a factor of 6, that means 6, when you divide by 2, you will get the remainder 0. And again, 3 is also a factor of 6. So divide 6 by 3. What do you get in remainder? Again 0. That means the factors, they completely divide the number, leaving remainder 0 here. Now we have an example for you. Write all the factors of 12. So what's an easy way to write the factors of 12? Let us see in how many tables and by multiplying which numbers do you get 12. So the first possible combination is 1 times 12 is 12. So this is one combination. Then read the table of 2. Do you get 12 there? Yes. 2 times 6 is also 12. So this is another combination for 12. Third, let's try for 3. 3 times 4 is 12. So this is yet another combination. When you go to the table of 4, you say 4 times 3. It is just the same as 3 times 4 by just swapping the numbers or changing the order of numbers being multiplied. So we have 3 such multiplication facts which give you the product 12. Now out of these 3, we need not go ahead. Once the numbers get repeated, they get swapped, we stop trying for the tables ahead. Now out of these 3 multiplication facts, we will get all the factors of 12. How? We can list them. From here, which are the 2 factors of 12? 1 and 12. From the second one, 2 and 6 are the factors, and from the third one, 3 and 4 are the factors. So the factors of 12 are 1. With 1 you have 12. If you write in this way, all the factors will be listed and you will not miss on any of them. With 2, you get 2 6s are, and with 3, you get 3 4s are. So these are the 6 factors of 12. So what are factors, can we recall? The numbers that exactly divide another number, leaving remainder 0, right? Now, if you have to write all the factors of 24, we can write the multiplication fact. And quickly what you can do is, always remember any number is divisible by 1 and every number is divisible by itself also. So this will be the smallest factor of any number. What is it? 1. And this will be the biggest factor of any number. What is it? The number itself. So 1 and 24, 1 will be in the beginning, 24 at the end. Now let's check, is 24 divisible by 2? Yes. So you can quickly write here, it is divisible by 2. What do you get? What is the other number here in the multiplication fact that gives you 24? 2 12s are 24. So from the back, from the end, now you will write 12. So you get another pair. Is it divisible by 3? Yes. So 3 8s are 24. Is it divisible by 4? Yes. 4 6s are 24. Is it divisible by 5? No, not divisible. Now after 5, what is the next number you should check? 6, which is already here in the list. So you will stop the check here and the list of all the factors of 24 is here with you. I am sure this will be easy for you to do. Okay. Now we'll try this with some questions ahead. Now what are the properties of factors? The smallest factor of any number I have just told you is 1, because every number is divisible by 1. So the smallest factor of every number is 1. Every number is a factor of itself and it is the biggest factor in fact, because you can divide any number by itself. So every number is a factor of itself. Factors of a number, they are always smaller than or equal to the number. So when you look at the list of all the factors of 24, what do you see? The biggest factor is the number itself and all others are smaller than it. When you just found out the factors of 12, you got 1, 12, 2, 6, 3, 4. Here also what you observe, all the factors are either equal to or smaller than the number. Let's write the factors of 15. 1, 15. It's not divisible by 2. Come to 3. 3 5s are 15. It's not divisible by 4 and your search ends here. So again, what do you see? This is the number itself, which is the biggest factor, and all other factors are smaller than it. So always remember, the factors are either equal to or smaller than the number. Next, a number can have only limited number of factors. The list is not endless, right? What do we mean by that? Look at the factors of 15. Let's write the factors of 2. 1, 2. Let's write the factors of 1. It is just one factor. So what do you see? The number of factors, it can be less, it can be more. See, 1, 2, here you have 4, here you have 6, here you have 8 factors. And for still bigger numbers, you can have many more factors. But ultimately, where will the number of factors, where will your search end? The last factor will be the number itself. Beyond that, you cannot go. So that means the number of factors for any number is limited. It may be big or small, but it will be limited. Your search will definitely end somewhere. Okay. Now, 1 is the only number with just one factor, because 1 is divisible by 1, which is the number itself. So, it has got only one factor. This is the only number. Now, here you have an exercise. Find the factors of the following numbers and complete the table. So, let's do this way. It will be easier. That will give you the confidence also. So, what will you write at the end? You will write 20. Good. Now, next number you will be writing is good, because it is divisible by 2. So, you write here 2. So, 2 tens are 20. Write 10 here. Next, what is the number? 4. Good. So, when you divide by 4, what do you get? You get 5. And you get the number side by side. The search ends here. 15 we have already written. Let's write for 42. 1. On the other side you get 42. Okay. See, if you write them side by side, I'm sure, I can assure you that you will not miss any of the factors. Is it divisible by 2? Yes. So, when you write 2, quickly divided by 2, what do you get? 2 21s are. So, immediately write the other pair from the multiplication fact. Now, have the check for the divisibility of 3. 4 plus 2 is 6. Is it divisible by 3? Yes. So, let's write 3 here. What will be the other number? Divide and see. 3 ones are 3, 3 fours are 12. So, it will be 14. Now, is it divisible by 4? No. Is it divisible by 5? No. Is it divisible by 6? Yes. 6 sevens are. So, from the beginning 6. From the end 7, and the two numbers are just consecutive numbers. The search ends here. So, here you have the list of all the factors of 42. Easy? Have you understood also? I am happy to see your smiles, children. So, I am sure the rest of the parts you can do yourself. Be confident about it. Now, in this you have to write yes or no. Factors of 12. So, this is the list of all the factors of 12. Just see, is it correct? 1, 2, 3, 4, 6, 8, 10, 12. The very first thing is 1 is okay, 2 is okay. So, you just have to check. 3 is okay, 4 is okay, 6 is also okay. What about 8? Can you divide 12 by 8, leaving remainder 0? No, you get the remainder. That means this sentence is not correct. Factors of 16, is it all? 1 is okay, 2 8s is okay, 4 4s are 16. Oh yes, this is the only list. That's perfect. 1 is the factor of 1 only. Only 1. No, 1 is the factor of every number. Yes, so this is no. Now the factors of 30 are, check out whether all the factors are given. Anything is any number short? Is any number more? And write down yes, no yourself now. Now, let's think the number 13 has only two factors, 1 and 13, 1 and 13. So, the smallest factor 1 and the number itself. Such a number which has only two factors, 1 and itself. Such numbers are called prime numbers. Okay. So, because 13 has just two factors, 1 and itself, so it is a prime number. The factors of number 10 are 1, 3, 5, 7, 10. Is it correct? 1, 3, 5, 7, 10. Are these the factors of 10? They are not. Let us list the factors of 10. What are the factors of 10? 1, 10, 2, 5. That's it. So, it is 1, 2, 5, 10. Now, what do you think? Is it correct? No, it is not. So, your correct answer here is no, because the factors for 10 which are given here are not correct. Now, let's come to common factors. When we talk about something common, do you think we can see something common in just one single thing? If I say, what is common in you? I need to compare it with somebody, isn't it? So, for finding anything common, we must have at least two. So when you have to find the common factors, that means you have a list of factors of at least 2 numbers. Then only you can find the common factors. So if you have to find the common factors of 30 and 20, we will first list all the factors of 30. My way of directly listing. What are the factors of 30? 1, 30. Then is it divisible by 2? Yes. 2, 15. Then 3, 10s are. 4, not possible. 5, 6 are. And your search ends here. Let's list the factors of 20 now. We'll take another color for it. 1, 20. 2, 10s are. Okay, so they are here. 3, not possible. 4, 5s are. It's done. Your search ends here. So here we have listed the factors of 30 and 20. And you know, in this common shaded region, we have put all the factors which are common to both the numbers. So for 30 and 20, the common factors are 1, 2, 5 and 10. So these are the common factors of 20 and 30. This is how we find out the common factors of any numbers. It can be more than 2 numbers also. So we'll just find out which are the common factors there. For which we first need to list the factors of those numbers. Now here's an exercise for you. Find the common factors of the following numbers. So let's do it for 15 and 9. So what are the factors of 15? 1, 15, good. 3, 5. That's it. The second number is 9. What are the factors of 9? Let's list them again. 1, 9 and 3 3s are 9. So what are the common factors here? 1, 3. So we'll say common factors of 15 and 9 are 1, 3. That's it. Easy. So I'm sure you can do rest of the parts yourselves. Let's move to the next. Write the factors of the following numbers in their respective circles with their common factors in the center. So here you have to, let's take just one part, 20 and 18. Let's write the factors of 20. 1. Okay. So 1 will definitely be common to both the numbers. 1 is the factor of all the numbers. With 1 you get 20. Now 2. Yes. 2. With 2 you get 10. Is it divisible by 3? No. What about 4? Yes. 4 and 5. Now let's write the factors of 18 in a different color. So with 1 we have already written in the common part. This is common region. So this is 18. Now 2 and 9. Okay. 2 we have written here, but it is common to both. So let us take it away from here and we'll write it in the common region. This is 2. With 2 you get 9. Is it divisible by 3? Yes. 3 6s are. So your one number is here, another is here. So what are the common factors of 20 and 18? These are the common factors of 20 and 18. 1 and 2. That's it. So I'm sure the rest 3 you can do yourselves. That's great. Now coming to prime and composite numbers, we have just read that the numbers which have only 2 factors. Do you remember we found out the factors of 13? How many factors were there? Just 2, 1 and 13. So if a number has only 2 factors, 1 and itself, such numbers are called prime numbers. And if they have more than 2 factors, they are called composite numbers. So the numbers that have only 2 factors, 1 and itself, only 2 factors, they are called prime numbers. Now, what you have to see, do you remember the list of factors we started? And at the bottom, I wrote 1. This is the number which has only 1 factor. For prime numbers, I'm saying it should have 2 factors only, and the numbers that have more than 2 factors, they are called composite numbers. So what do you have to say about 1? Does it have 2 factors? No, so it is not prime. Does it have more than 2 factors? No. So it's not even composite. What is it? It is neither prime nor composite, children. And this is the only number that is called a unique number. Okay. So one is neither prime nor a composite number. We call it a unique number because this is the only number with just one factor. Okay. Now the numbers that have more than two factors, they are called composite numbers. So here we have an exercise for you. Sort out the following numbers as prime or composite numbers. So we'll just see how many factors does that number have. Let's see how. 13 we have already done. It is 1, 13, only two factors. So this is your prime number. Now it's not possible to list all of them, but what you have to remember is composite numbers should have at least three factors. They should be more than two. Let's come to the next number, 54. Now when you look at 54, 1 is a factor, number itself is also a factor. So two factors already there. Now look at the last digit. Use your divisibility tests. Look at the last digit. What is it? 4. This is 4. That means it is an even number. It is definitely divisible by 2. So another factor. Now we have at least 3. There can be more. I'm not saying just 3, but at least 3. So you need not find out other factors. You just have to tell whether it is prime or composite. It is composite because it has at least 3. I need not find out ahead. Now look at the number 37. What are the factors? Just see. 1, 37. Two factors are definitely there. Let's see if it is divisible by other numbers also. 2, not possible. 3, not possible. 4, not possible. 5, no. 6, no. 7, no. When you keep on checking, you will realize that 37 has only two factors. So this is again a prime number. And for you to learn the list of prime numbers, at least from 1 to 100, you will be getting a list here, right? So for all these numbers, you just have to check out whether they have two factors or more than two factors, right? Accordingly, you will write whether they are prime or composite. You will write them in the appropriate boxes. But remember children, this is 37. It has only two factors. That does not mean you will just stop your search whenever you see an odd number here. For example, if you look at 45, 5 is at the ones place. That means it is divisible by 5 also. So that becomes your third factor. Okay. So just be careful. We'll just not move on with the eyes closed that, oh, it's not divisible by, and we'll move ahead making it a prime. No. Please check out. Look at 27. What about it? This also has 7 at the end. But then when I use my divisibility test for 3, I know 7 plus 2 is 9. So it is divisible by 3. So just be careful before skipping any of the numbers. Now next question is, answer the following questions. Write down all prime numbers less than 30. So can we write? Is 1 a prime? No. 2? Yes. 3? Yes. Is 4 a prime? No, it's composite. Then 5. Next is 7. 8? No. 9? No. Is 9 not divisible by any number? It is divisible by 3. So it is not a prime number. 10? No. 11? Definitely. 12? No. 13? Definitely. 14 again? No. 15? No. It is divisible by 3 and 5 both. Then 16? No. 17? Yes. So this way we continue. 19, 21 is also not a prime number, children. Just be careful before just differentiating. 21 is not. 23 is, and after that 29. So this is the last prime number before 30. So you will be checking for each of these numbers. Now next is, write down all prime numbers between 75 and 100. Write down all composite numbers between 20 and 30. So leave the prime numbers, write down the remaining numbers. Which is the smallest composite number? So your counting starts from 1. Neither prime nor composite. 2 is a prime number. 3 is another prime number. Now 4 is a composite number. So your composite numbers start from 4. So this is your smallest composite number. And these two questions, now you will be listing yourselves. Now here's an activity for you. Think more, make a chart of factors of numbers from 2 to 10. So you will be writing number here, write down the factors of that number and see, are there only 2 factors? Then it is prime. If there are more than 2 factors, then it is composite. So you have to complete this chart for numbers from 2 to 10 and then identify the numbers as prime or composite. You can go up to 20 also. So you can find the factors of numbers up to 20 and identify them as prime or composite numbers. Now coming next is multiples. What are multiples? Multiply. So the numbers that you get after multiplication are called the multiples. If you have 5 times 6 is equal to 30. So 30 is called a multiple of 5. 30 is also a multiple of 6 because we are getting this number by multiplying these two numbers. So 30 is a multiple of 5 and 6. Multiple of a number is the number into any counting number. So if I ask you which is the 5th multiple of 7, so you'll just multiply 7 times 5 is 35. This is how we get the multiples. Write the first 5 multiples of 2. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. So these are the first 5 multiples of 2. So just multiply by the numbers and you get that multiple. Is 84 a multiple of 6? That means we will check whether 84 is divisible by 6 or not. When we did factors, we learned if we are saying 2 times 3 is equal to 6. Why is 6 a multiple? You can just divide. 6 divided by 3 is equal to 2 and 6 divided by 2 is equal to 3. So just to check whether 84 is a multiple of 6 or not, you can just check whether you get the remainder 0 on division or not. If you get remainder 0, the number is a multiple. So let's divide 84 by 6. What do you get? 14 is the quotient and remainder is 0. So yes, definitely 84 is a multiple of 6 because by doing this division, we have shown that 6 is a factor of 84. Now the multiple is just the opposite. So we say 84 is a multiple of 6. Is 108 a multiple of 7? So just the same way, divide and check out, do you get the remainder 0? No. That means 108 is not a multiple of 7. Find the 4th multiple of 8. So for the 4th multiple, you will multiply 8 by 4. That gives you the 4th multiple of 8 and that is the number 32. Just like we have done some properties of factors, we have properties of multiples also. Every number is a multiple of itself. So 5 times 1 is 5, 12 times 1 is 12 and so on. A number can have unlimited multiples. Why? Because the counting does not end. Whatever multiple you say, I can always say a multiple greater than that. So numbers are endless. That is why multiples are also endless. They are limitless. Every number is a multiple of 1. You multiply any number by 1, you get the same number. So every number is a multiple of 1. Next is the multiples of a number are either greater than or equal to. What we learned in factors? Factors are either equal to or smaller than the number. But in case of multiples, because when we multiply, we will be getting bigger numbers. So the first number we multiply is 1, we get the same number. So the number itself is the smallest multiple. But as you move ahead, the multiples grow bigger. So multiples can either be equal to or greater than the number. Now, every multiple of a number is exactly divisible by that number. So if you have 14 as a multiple of 2, so you will divide and exactly divisible means remainder 0. That means it is a multiple. If you look at 15, You can divide it by 5 to get 3, remainder is 0. So we say 15 is a multiple of 5. The first multiple of every number is the number itself, because you multiply by 1 and you get the same number. Here's an exercise for you. Write the multiples as directed. So first 4 multiples of 7. That means 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. So I got the first 4 multiples. Find the first 5 multiples. This is the 5th multiple of 9. Here you have to find just one, 5th multiple. So 9 times 5 gives you 45. This is your 5th multiple of 9. So do the rest parts yourself. Color the circles which are not the multiples of numbers given in words. So the numbers are not the multiples. Please see this. They are not the multiples. That means what do you have to do? See the multiples and then color the remaining ones. For 4, 4 2s are 8, it is divisible. 4 3s are 12, it is divisible. 4 4s are 16, 14 is not divisible, so it is not a multiple. 4 4s are 16, 4 5s are 20, again 18 is not a multiple. And 4 6s are 24, again 22 is not a multiple. So let's do the rest parts like this. Now solve and answer. Give a reason for your answer. Is 90 a multiple of 5? So what you will do? You will multiply 90 by 5. So when you multiply 90 by 5, do you get a remainder? Remainder is 0. So 90 divided by 5 is equal to 5 ones are 5, 5 8s are 14. So remainder is 0. That means 90 is a multiple of 5. Similarly, you will do the remaining 2 parts. Now, just like we have done common factors, we can find out common multiples also. So here again, you will have to list the multiples of the numbers first, then find out the common multiples. Like if you have to find out 2 common multiples of 2, 3 and 4. So first let's write the multiples of 2. 2, 4, 6, 8, 10 like this, and then the multiples of 3, 3, 6, 9, 12, 15, 18 and so on. And the multiples of 4 are 4, 8, 12, 16, 20 and so on. So when you just list these multiples, you find that 12 and 24 are the common multiples. We'll have many more because the list is endless, children. I have been telling you multiples are endless. But then these are the first 2 common multiples of 2, 3 and 4. What are these? 12 and 24. Here's an exercise for you. Complete the table. The numbers are given to you. You'll write the multiples, then you will write the common multiples. So for 2 and 3, let's write the multiples of 2 first. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10 like this. For 3, we will write the multiples of 3 as 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. Now what do you see common here? What number is common? 6 is common. So when you write 6 in the common multiples, you can go ahead. All the other common multiples will be the multiples of 6. So your next common multiple will be 12, next will be 18. So you can write just 2 or 3 because again the multiples are endless. Similarly, you will be doing for rest of the parts. Now write the multiples of the following numbers in the respective circle with their common multiples in the center. So if you have to list the multiples of 3, again see I am mentioning it repeatedly, they are endless, so you have to stop somewhere. 3 times 1 is 3, 3 times 2 is 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24. Right? Now when we write the multiples of 4, what do we get? 4 times 1 is 4. 4 twos are 8. 4 threes are 12 is already written here. 4 fours are 16. 4 fives are 20. 4 six are 24 is also written here. So this way you get the common multiples of 3 and 4 in this common region of the two circles. So you'll be doing the rest of the parts yourselves. Coming to the next topic, we have prime factorization. We have already learned what are prime numbers. So when you have to do prime factorization, any composite number can be written as a product of prime numbers. How? We'll just learn, but this process is called prime factorization. There are different methods of doing prime factorization, out of which the first method is the factor tree method. So in this factor tree method, what do? We make the branches of a tree. How? Suppose we have to find out the factors of 24. So what you will do? We will write 24 at the top. Now we make two branches of 24. You can take any of the multiplication fact, not 4 and 6. You can even take 2, 12 also. So if we go for 4, 6 as the two factors, now we find, are these prime numbers? No, both of them are composite. So we will again make the branches of these numbers. So 4 has factors 2 and 2, 6 has factors 3 and 2. And what you see finally, all these are prime numbers. So the search ends here. Now another way is 24. We know even 3 8s is 24. So if you take these two branches, 3 is a prime number. Now leave it. Come to 8. 8 is a composite number. We'll make branches again. So 2 4s are 8. Now 2 is a prime number. Leave it. Come to 4. Make the branches again. So 2 2s are 4. Now you are here with all the prime numbers. The task is done. Another way is, what I said is 24 can be written as 2 into 12 also. So leave this prime number. Make the legs branches of 12. 3 4s are. 3 is a prime number. Leave it. Make the branches of 4. 2 2s are. So again, all these leftover parts are prime numbers. So your task is done. And what you see? 2 2 3 2, 2 2 3 2 and 2 2 2 3 2. In any of the ways, whatever way you start, you get the same factors finally, which are prime numbers. So we say the prime factorization of 24 is equal to 3 times 2 is being multiplied and just 1 time 3. So the product of all these prime numbers finally that you get is called the prime factorization. The other method, this is the factor tree method. The other method is the division method, in which we write the number at the top. We write the first prime number here by which it is divisible, and we carry on by writing the quotient below it. So if you have to find the prime factorization of 96, we can see 6. This is an even number, so it will be divisible by 2. So 2 4s are 8 and 2 8s are 16. So you get 48 when you divide 96 by 2. Again it is even, so divide by 2 again. 2 2s are 4, 2 4s are 8. Again 2 12s are 24. Next again 2 6s are 12, 2 3s are 12 and 3 1s are 3. So we will continue with this process till you get 1 as the quotient at the end. Now what is the prime factorization here? 96 is equal to the product of all these prime numbers. How many times 2? 1, 2, 3, 4, 5 times 2 and just 1 time 3. So 96 is equal to 1, 2, 3, 4, 5 times 2 multiplication of 2 and just 1 time 3. So this is also an easier way. The only thing to remember is when you divide, normally when you divide you write the quotient up, but here you have to write the quotient below, and in the next step this will be your dividend. Okay, so let's move ahead now. While writing prime factors, write the factors only once. So put commas between the numbers, right? But when you are doing prime factorization, you have to put the multiplication sign and you have to write the prime number as many times as it comes in your process. Okay, So prime factors of 18 are 2, 3. But prime factorization of 18 will be 2 times 3 times 3. So here 3 will come 2 times. You have to write it 2 times. Okay. So you have to remember this. Now complete the following factor 3. What is the other branch of 30 here? 3 tens are 30. Now 10 is not a prime number, so we'll make branches again. Yes, this is the factor tree completed. So this is 10 here, this is 5 here. So you can do rest of the parts yourselves. Now create all possible factor trees of 64. So you'll be creating like this. Just like we have done different ways for 24, starting with a different branches. Similarly, you will be making for 64. Write the prime factors using the division method. Here you have to write prime factors. So prime factors you have to list like this. So if you have 20, you have to do it using division method. So start with 2. Tens are 20. Now again 2. Fives are 20. Now 5. 5 ones are 5. That's it. So what are the prime factors here? Only 2 and 5. So we'll write prime factors of 20 are 2, 5. And when they ask you for prime factorization, then you will write 20 is equal to 2 times 2 times 5. Okay, so remember this. You'll be doing rest of the parts yourselves. Now here's a hots for you. Complete the given factor tree. You have to go upwards now. So the 2 factors here for this is 3 and 3. So what is the number here? 3 3s are 9. Now with this branch, what is the number here? 9 2s are 18. And with these 2 branches, what is the number here? 18 2s are 36. So we reach back to the original number this way, going backwards. So do this and have fun, children. Now you have chapter at a glance. A factor of a number is some number that divides it exactly, leaving remainder 0. 1 is a factor of every number and it is the smallest factor. Every number is a factor of itself and it is the biggest factor also, remember. 2 is a factor of every even number, but it is not a factor of an odd number because odd numbers are not divisible by 2. So 2 is a factor of all even numbers only. A multiple is a factor multiplied by another factor. So how do you get the multiple? Multiplying a number by another number. And these 2 numbers are called factors. So multiple is a factor multiplied by another factor. Every number is a multiple of 1 and itself. A number cannot have a multiple smaller than it. Multiples are always equal to or greater than the number. And what about factors, children? They are always equal to and less than the number. Remember this. Now, exercise for you. So, this is for the competency base. 23 is a multiple of 1. Yes, every number is a multiple of 1. Is it a composite number? No, it has only 2 factors. Is it a prime number? Yes, it is a prime number. So both A and B are correct. That means option D is correct. So what do you learn from this question? You will not stop as soon as you get your answer because more than one options can be correct, children. So you please look out for all the options and pick out the best one. Now prime factorization of 24 is, you can quickly do prime factorization and see what is the correct answer. And in place of that, you can multiply and see whether you get 24 or not. But what you have to remember, look at the first option here. They are asking for prime factorization. Is this a prime number? So this is definitely not your answer. Is this a prime number? So even this is not your answer. Now look at these 2. Let's multiply and see when do you get 24. 2 2s are 4, 4 2s are 8, 8 2s are 16. Is it? No, even this is not. Let's check this. 2 2s are 4, 4 2s are 8, 8 3s are 24. Yes, this is perfect. This is your prime factorization of 24. Now, miscellaneous exercise, take the correct option. Which of the following is not a factor of 36? You will be checking out yourself by dividing. The factors of 8 are, just check out which of these are the factors. Which of the following is a common factor of 4 and 8? What is the common factor? 1 is a common factor, 2 is a common factor, 4 is also a common factor. So, only this is the correct option. The multiples of 3, find out the list yourself. Which of the following is a common multiple of 7 and 9? You can quickly make the list and check out. Okay. Now, subjective type questions. When I add two odd one-digit numbers, the answer is always odd and a prime number. Is it true or false? You can quickly check. Let's take any two odd numbers. So, two odd one-digit numbers, 3 and 5. What is the sum? 8. What are they saying? The answer is always odd. No, it is even. And when a number is even, it cannot be prime except for 2. Okay. So, this is false. Color the circle with the correct answer. 22, 12 and 14 are all multiples of which number? Are they multiples of 2 or they are the multiples of 7? They are all the multiples of 2. 22 and 12 do not come in the table of 7. Now 36 is a dash of 6. Is 36 a factor? What have you learned? Factors are always equal to or smaller than the number. Here what do you see? 36 is bigger but 6 is smaller. So it is definitely not a factor. It is a multiple. And the next question says, Harry and Rishabh are climbing the stairs of their respective buildings. Harry has 11 steps for each floor and total number of floors in his building is 12. So he'll be going 11 steps, 11 steps, 11 steps like that up to 12 stories. Rishabh has 14 steps for each floor and his building has 10 floors. That means he'll be going 14, another 14, another 14, another 14. How many times? It has got just 10 floors. So both count the number of steps climbed for each floor and write it down. What is the pattern of numbers they both get? So just see 11. Then for the next floor total, he'll be going for 22, then 33 like this. You'll be going up to 12 floors. Similarly, you will be doing for 14. 14, then 28, then 42 and see and complete the pattern up to 10 floors. Now, let's think. If one toffee costs ₹2, how much money would you need to eat 10 toffees? Definitely 20. You got it correct. How did you get it? Okay, by multiplication. Smart children. Every day for 5 days you eat. So that means 20 rupees in one day. So 100 rupees in 5 days. What would happen if you eat 10 toffees every day? Is it good? Every day you are having 10 toffees. What will happen? Yes, you will have the cavities, right? So it's not good to have too many sweets daily. Is it good for your health? Definitely not. And do you eat a balanced diet every day? Do you include everything in your diet? Nuts, fruits, vegetables, and then pulses, cereals, everything? So that is the best way to keep yourself healthy. You should have fats also in your diet. Everything should be covered because you are growing. Your body needs everything. You do lots of physical activities and you are growing also. So you should have a balanced diet, children. Now, here's a lab activity which your teacher will make you do in the class. Have lots of fun doing this activity and we will be coming up with more interesting sessions in maths. Till then, happy learning, children.